Hey students, this is lesson 3.3, proving lines parallel. We're going to learn how to determine whether two lines are parallel. And we're going to use some of the ideas we learned in the last lesson, but we're going to be using the converse. So go ahead and do this review, and I'll check back with you. All right, so here's the postulate we're going to use. Postulate 3.1, that was the one we learned in the last lesson. Corresponding angles postulate says if a transversal intersects two parallel lines, then corresponding angles are congruent. And this new postulate is just the converse of that. So you can think about what that is and see if you can identify it. Okay, and then these are the converse of the theorems we learned in the last lesson. And what they give us is the way to tell if two lines are parallel. So the first one, if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So if you have that the angles, the alternate interior angles are congruent, then you know the two lines are parallel. Converse of the same side interior angles theorem says that if two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. And the converse of the alternate exterior angles theorem says that if two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So theorem 3.4, that's we need alternate interior angles to tell if two lines are parallel. So if 4 and 8 are congruent, then the two lines would be parallel. The second one, theorem 5, that's the same side interior angles. So if angle 3 and angle 8 are supplementary, then the two angles would be parallel. And the last one, theorem 3.6, if angle 1 is congruent to angle 7, those are alternate exterior, then the two lines are parallel. All right, so we're going to use those and justify it with these new rules. So we want to know which lines are parallel if angle 2 is congruent to angle 3. So we want to think about what kinds of angles they are. We're going to use this as the transversal right here. And with respect to that transversal, angle 2 is congruent to angle 3 is given. And we notice that those are alternate interior angles. So we're going to say that these two lines must be parallel because those are the two lines that make 2 and 3 alternate interior angles. So, so M is parallel to N, and that is by the converse of the alternate interior angle theorem. All right, you try that. I'm going to introduce you to a new kind of proof here, writing a flow proof. It's called a flow proof, and computer engineers use these kind of proofs quite a bit. But what we're going to do is we're going to show that A is parallel to B, given that the measure of angle 5 is equal to 40 and the measure of angle 2 is 1/4. It says writing a flow proof of theorem 3.6. This is theorem 3.6. This is just an outcome of theorem 3.6. So we're going to start with a couple of givens here. And that is, and I'm going to write it like, when you do a flow proof, you use boxes and arrows. So I have two givens here, and that the measure of angle 5 is equal to 40. And also the measure of angle 2 is equal to 40. And those are both given. We'll just write the reasons right underneath them. And now I'm going to bring those two things together to form the idea that if those two things are true, then we can say that the measure of angle 2 plus the measure of angle 5 is equal to 180. And that's just substitution. So we're adding the two angles together, and they're equal to, oops, I wrote this, I need 140 there. So, and that's substitution. So we'll write that rule on it up. Now, as a full proof, we're going to have arrows going to, so we're bringing those two things together to form that idea. So now we have that, and from that we can say that by the definition of supplementary angles, we can say angle 2 and angle 5 are supplementary, and that's just the definition of supplementary. And then from that, since angle 2 and angle 5 are supplementary, we can see from the diagram that they're the same side, we can say that the two lines are parallel. I need one more box, one more arrow, and I'm going to say that A is parallel to B, and my reason for that is the converse of same side interior angles theorem. All right, I'm going to let you try that. All right, so here we have another problem. It says a fence gate at right is made up of pieces of wood arranged at various directions. Suppose angle 1 is congruent to angle 2. Our lines are and S parallel. Explain. So we have this is given. So we have measure of angle 1 is equal to the measure of angle 2. We also can see that those are alternate exterior angles. So we can say that R is parallel to S, and that's by the converse of the alternate exterior angles theorem. And the next problem, if the measure of angle 1 equals 65 and the measure of angle 2 equals 115, are the lines A and B parallel? So what I would do first is just say, well, 65 plus 115 is equal to 180 from just adding them up. And since that's true, we can say that they're supplementary. Angle 1 and angle 2 are supplementary. And we also can see that they are same side interior angles. So we can say that A is parallel to B, and that's by the same side into the converse, keep forgetting converse, same side interior angles theorem. All right, you try that. All right, problem 4. What is the value of x for which A is parallel to B? Well, if A can be parallel to B, then these two angles need to be supplementary. So we're going to say 40A plus 3x plus 3 is equal to 180. And that's from the same side interior angles theorem. So 3x plus 51 is equal to 180. That's just simplifying. So 3x is equal to 180 minus 51, which is 129. And dividing both sides by 3, we get x is equal to 43. And that's using the division property of equality. You can go ahead and try that. All right, that's the end of the lesson. Go ahead and do the lesson check and be ready with that the next time we meet in class.